Hello, and welcome to the second video of our first example. In this video, we will begin by creating static analysis settings using the static analysis settings component in the Dlubal tab. First, we will enter the static analysis settings number. We will enter the number 1. Then, we will select the analysis type using the value list. In this example, we select geometrically linear analysis, as you can see. You can also select another analysis type, like large deformation, or second-order theory, p delta. For exceptional handling, we insert the Boolean toggle command and leave it as false. True can be used when we want to remove failing members individually during iterations. Afterwards, we want to create load cases using the load case component in the Dlubal tab. For this example, we would like to create 2 load cases. The first will be self-weight and the second will be imposed load. Next, we will enter all the inputs required for these load cases. We will start with the first load case. We enter number 1 for the load case number and static analysis settings using the number slider command. We enter self-weight for this load case name using the panel command. In order to define an action category, we need another component, which is called load case classification. You can find it in the Dlubal tab. For this component, we have to select the standard group, for example, EN 1990. Action category, permanent. And design situation type, ULS, permanent and transient according to equation 6.10. To activate the self-weight and the load case, to solve, we insert the Boolean toggle command and set it to true by double-clicking it. Now, we would like to copy this load case by holding the Alt key and dragging after selecting all elements. Afterwards, we need to modify some parameters for this load case. We enter the number 2 for the load case number. The load case name has to be changed to imposed load. We have to disconnect the self-weight for this load case by holding down Ctrl and dragging. Otherwise, it will be calculated twice. We also want to change the action category. For example, we select imposed load category A. Now, we connect each component to the RFEM component by holding the Shift key and dragging. Next, we need to create design situations using drag and drop for the design situation component in the Dlubal tab. In this example, we will define 2 design situations. The first will be ULS, ultimate limit state. The second will be SLS, serviceability limit state. For this component, we also have to enter the number and the design situation name and type. For the number, we enter 1. And for the name, we enter ULS. For the design situation type, we need to insert another component, which is called load case classification. We enter EN 1990 for the standard group. Permanent G for the action category. And ULS permanent and transient, according to equation 6.10 for the design situation type. Then we connect one design situation type to the other design situation type in the component. To create the second design situation, we copy the first one by holding the Alt key and dragging after selecting all the elements. We have to change the number to 2. the name to SLS, and the design situation type to SLS characteristic. Afterwards, we connect both components to the RFEM component. In the next step, we will create load combinations. Therefore, we insert two components. The first is load combination, and the second is load combination items. We need to enter the numbers and factors for both load cases. We can do this using the panel command. Make sure to select multi-line data by right-clicking the panel. Now, we enter the numbers of the load cases for the two design situations, ULS and SLS. For ultimate limit state load cases, they will be combined as follows. Load case number 1. Load case number 1 plus load case number 2. We name these combinations by inserting the scribble command, which you can find in the Params tab. Now, we write a name, ULS combos, and make a group. We repeat this for the serviceability limit state and change the name to SLS combos. The same procedure will be applied for the factors. We enter the respective factors as follows. 1.35, 1.35 plus 1.5 for the ultimate limit state. 1 plus 1 for the serviceability limit state. To create combinations, we have to insert the entwine component. As you can see, we have 4 inputs and 3 branches. Therefore, we need to add a new branch by clicking the plus sign. Now, we connect all inputs to this component. We insert the panel command to read the information in this command. After that, we connect the load case numbers to the load case number in the load combination items, and the load case factors to the factor in the load combination items component. As you can see in the panels, 0, 0 from the first panel will be combined with 0, 0 from the second panel, and so on. Then we connect the load combination items component to the item in load combination component. Then, we enter the load combination name by inserting the panel command. We have 4 combinations, 2 for the ultimate limit state and 2 for the serviceability limit state. Therefore, we enter CO1 ULS, CO2 ULS, CO1 SLS, CO2 SLS. For the design situation number, we enter 1 and 2, because we have 2 design situations. This means that the ultimate limit state combinations will be connected to design situation number 1 and the serviceability limit state combinations will be connected to design situation number 2. Make sure to set the multi-line data for the panels and set the graph for the combination name and design situation number to get the right load combinations. We also have to enter the static analysis settings number. For that, we enter number 1. After that, we connect the load combination component to the RFEM component. In the next step, we will apply the load on members as imposed load. For that, we need to insert the member load component from the Dlubal tab. We enter the load case number. In this example, we enter the number 2 for the imposed load. We also need to enter the member number. We have 2 members, so we enter 1 and 2 using the panel command. The load type, load distribution, and load direction can be defined using the value list command, as you can see. For load type, we select force. For load distribution, uniform. And for load direction, global Z, or user-defined W true. To enter the load magnitude, we will insert a number slider command. Be sure to enter the load magnitude in Newton. For example, we enter 5,000 newtons. Next, we will create groups as we did in the previous video. After connecting all components to RFEM 6 component, we double-click the Boolean toggle command to perform the export. As you can see, we need to reverse the direction of this load using the negative component. You can find it in the Maths tab. Thank you for watching. If you like this video, don't forget to like and subscribe.